Yeah, after electrons can be filled in a shell unless the outer, according to Niels Bohr. So, what are the steps that are involved in filling the electrons? See, according to the atomic number, we all have learned about atomic numbers. So, the number of protons and number of neutrons are nothing in hydrogen atom, and the number of electrons are one. Equal number of electrons and equal number of protons according to an element. So in the arrangement of distribution of electrons in this shell will be as there is only one electron and it can be filled only in the K shell, and the valency will of course will be zero. And for helium, as it is an inert gas, the valency will be zero. Lithium, the arrangement of electrons will be in the K shell, two electrons, and in the L shell, one electron. So the valency will be one. Like this, according to the atomic numbers, he has arranged the distribution of electrons in different shells such as K shell, L shell, M shell, and N shell. Okay. Now we shall see. So if you see the structures for hydrogen, one electron is present in the outermost orbital. For helium, it is stable, two electrons. For lithium, two electrons, one electron in the outermost shell. For beryllium, two electrons. Like this. These are the structures for first 18 elements. Next, we shall see what is valency. Valency is the combining capacity of an atom of an element. The electrons present in the outermost shell, whatever the electrons present in the outermost shell are called as valence electrons. If an atom's outermost shell is completely filled, they are called as inert or least reactive because there is no need for them to react with further atoms to form a compound, right? That is why they are completely filled or they are inert gases or they may be least reactive as well as because their combining capacity or valency will be zero. Of the inert elements, out of all the inert elements, helium will have two electrons in the outermost shell and the atoms of other elements have neon, krypton, xenon, radon will have 8 electrons in their outermost shell. So they are called as inert gases. They are inert and doesn't react with any other atom. Atoms having 8 electrons in their outermost shell is having octet configuration. Octet means 8 electrons in the outermost shell, so they need not react with anything, with any other atom. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability by either by losing electrons from the outermost shell or by gaining to get octet configuration or by sharing electrons. Okay, the number of electrons lost, gained, or shared by an atom to attain octet configuration is the combining capacity, or also called as valency of that particular element. Okay, for example, if you take hydrogen, lithium, sodium atoms can easily lose one electron and becomes stable, isn't it? Because if for lithium, one electron is present in the outermost shell, it can be easily be ready to give electrons. It can easily lose electrons and can form cation, that is Na plus. Magnesium can easily lose 2 electrons, so its valency is 2. And aluminium can easily lose 3 electrons, so its valency is 3. Carbon shares 4 electrons, so its valency is 4. Fluorine can easily gain 1 electron and becomes stable. Fluorine, which has atomic number is 9, so its valency will be 1. It can gain 1 electron easily and its valency will be 1. Oxygen can easily gain 2 electrons, so its valency is 2. Nitrogen can easily gain 3 electrons, so its valency is 3. Like that, so on and so forth, the valency is determined. Next is atomic number and mass number. Atomic number is given by the symbol Z, capital Z. The atomic number of an element is the number of protons present inside the nucleus of the atom of an element. For example, hydrogen atomic number will be 1 as there are 1 protons. Helium atomic number is 2, there are 2 protons. Lithium atomic number is 3 because there are 3 protons inside the nucleus. Mass number is given by the capital A symbol. The mass number of an element is the sum of the number of protons as well as neutrons. So totally together they are called as nucleons present inside the nucleus. Atomic number is only protons, positively charged particles, whereas the mass number is nothing but number of protons as well as number of neutrons present inside the nucleus of an atom. The mass of an atom is mainly the mass of the protons and neutrons. For example, if you take carbon, mass number is 12. Mass number is 12. That means 6 protons and 6 neutrons. That is mass is 12 units. Aluminium, mass number 27. Why? Because 13 protons and 14 neutrons are present inside them. Sulfur, mass number is 32. 16 protons and 16 neutrons, 32 units. See here, if you want to represent the mass number and atomic number is given as a subscript, whereas the mass number is given as a superscript as shown in the figure. So what is atomic number? The number of protons present inside the nucleus, whereas the mass number is nothing but the number of protons as well as number of neutrons. That means totally nucleons. Next we shall see what are isotopes. Isotopes are nothing but same element, or the atoms of the same element having the same atomic number but different mass numbers. Okay. For example, if you take hydrogen, deuterium and tritium, see here, the subscript is same. What is the subscript here? It is atomic number is same but the mass number will be different. So these types of atoms are called as isotopes. Isobars are nothing but same atomic mass will be present but of different elements. Isobars. So here it is reverse. The superscript will be similar. That is, mass number will be similar, but the atomic number will be different. Isobars of atoms of different elements having different atomic numbers. Different atomic numbers. That means subscript will be different, but same mass numbers. These pairs of elements having the same number of nucleons. Nucleons means protons as well as the neutrons are together called as nucleons. So this is all about structure of atom. In this we have studied about J.J. Thomson's atomic model, Rutherford's atomic model, and then the subatomic particles, what are isotopes, isobars, as well as the arrangement of electrons, as well as the valency of the particular element. So this is all about the structure of atom in a brief according to your 9th class standard. Okay. I hope you all have understood this structure of atom. Thank you.